Lesson 1-8 is entitled Represent Functions as Graphs. So in the previous lesson, 1-7, we represented functions as rules. We wrote the equations and we put them in tables. So we can actually use a graph to represent a function. If we're given a table that represents a function, each corresponding pair of input and output values forms an ordered pair of numbers that can be plotted as a point. The x-coordinate is the input and the y-coordinate is the output. So here we have it as a table: input x, 1, 2, and 4, output y, 2, 3, and 5. And these become the ordered pairs. X is paired with y, so we have the point 1, 2, 2, 3, and 4, 5. And recall that when you graph them, the x is horizontal and y is vertical. So you graph the point 1, 2, you come over 1 horizontally, 2 vertically, and then you plant your point. 2, 3, and 4, 5. So again, just reiterating, the horizontal axis is labeled with the input variable and the vertical axis is labeled with the output variable. Remember, the input variable is also, and I want you to write this down, this is the independent variable, and the output is the dependent variable. Okay, so we're going to get some practice in graphing the function. They will give you the function and they will tell you the domain. Every time we do this, I want you to make an XY input-output table. So our domain are the x's. We just simply put in 0, 1, 2, 3, 4, and 5, and the y's are the outputs. And I personally don't care if you make a vertical table or a horizontal table. So these represent, remember, the x values. So they're simply going to take the place of the x over here in the function. So 0 plus 3 is 3. 1 plus 3 is 4, 2 plus 3 is 5, 6, 7, and 8. So there are the values for our table. We also know that these values right here, the outputs, are called the range. So now we're going to go ahead and plot this. So we have 0, 3, 1, 4, 2, 5, 3, 6, 4, 7, and 5. My graph is not quite long enough, but we're going to plunk the little 8 right up there. When you actually have your own graph paper, make sure that it extends up high enough, please. And I'll just put it right there. Notice I didn't show any work, and that's okay with me on this. You do have to show your table, but I believe that you can add 3 to a value in your head. So, use your judgment call on that. I believe you probably can do this in your head. Now they're going to want us to write a rule for the function that's represented by the graph, and they want us to identify the domain and the range. The first thing that I want you to do is make a table. So we're going to pull these points off from the graph and put them on a table. So I have 0, 5, and 1, 4, 2, 3, 3, 2, and 4, 1. And we have to decide, what are we doing to these x values to get the y? So y equals something is done to x. So in this case, it looks like as the x's are increasing by 1, the y's are decreasing by 1. I can also see here that I start at 5. So I'm going to go ahead and start at 5. And if I take the 5 and I subtract the x, I get the next y. 5 minus 1 is 4. 5 minus 2 is 3. 5 minus 3 is 2, etc. So I'm taking the 5 and I'm subtracting off this x value, and that gives me the new y value. So my domain are the values 0, 1, 2, 3, and 4, and my range values are 5, 4, 3, 2, and 1. And yes, you could put the range as 1, 2, 3, 4, 5. It's the same thing. The order doesn't matter. All right, let's look at problem 4. Let's go ahead and make our table here. And let's see, we have to look at our scale. It appears that the horizontal scale is going by ones and the vertical scale is going by fives. So at 1 we get 10, at 2 we get 15, at 3 we get 20, and at 4 we get 25. So again, we're looking to see, how do I use the x's to get the y values? How do I use the x's to get the y values? So it appears that the x's again are changing by 1 and the y's are changing by 5. So I know that ultimately I'm going to multiply each x by 5 because as x changes by 1, y changes by 5. But I have to decide, what am I going to start with? There's a couple ways we can see this. We can see this in the graph, and if we continue the pattern, we see that we have the point 0, 5, and this lets us know that I start at 5. Or you can just look at this. I multiply this by 5, that gives me 5 plus 5 is 10. I multiply 2 by 5, that's 10, plus 5 is 15. 3 by 5 is 15, plus 5 is 20. 4 by 5 is 20, plus 5 is 25. So either way that you want to look at it, we can try to find this value here, which we know from our previous experience that's called the y-intercept, or again, you can look at the table and look at the graph to help you. Last problem. The table shows the number R of U.S. representatives for Texas as a function of time, t in years. So the representatives depend upon the time. And this is the year since 1930. So the 0 year means in 1930 there were 21 representatives in Texas. 10 years later, so this is 1940, 1950, 60, 70, 80, 90, and then this is the year 2000. So that's how we interpret this. They're asking us to graph the function. When you graph a function like this, you need to go ahead and label the axes in words, so with the variables. So this is years since 1930. And then up here we have number of representatives. Okay, so now we need to decide what our scale is going to be. So I'm going to go ahead and start with 0. And my x-axis, my input, is pretty easy. I'm just going to go in tens. So I've got 10, 20, 30, 40, 50, 60, and 70. But my y-axis, I don't want to start out at 20 or 21. You have to have an equal interval when you make your scale. So we're going to do what's called a broken scale. Excuse me, you just squiggle it a little bit. And I'm going to start out at 20. And I only have to go from 21 to 32. I do have enough space here to do that. But I'm going to go ahead and go by twos. So I'll go 20, 22, 24, 26, 28, 30, and 32. And now I'll go ahead and plot my points. So at 0 I have 21, so right in here. And at 10 I also have 21. At 20 it's 22. At 30 it's 23. At 40 it's 24. 50 is 27. 60 is 30. And 70 is 32. And here's what my graph looks like. They're not necessarily asking me any questions here. If they're asking me the trend of what seems to be happening, it does seem that as the years increase from 1930, the number of representatives also increase. I do want to take us back a slide because as I was working, I was thinking I forgot to finish the question. Right here on this problem 4, it's asking for the domain and the range, and I wouldn't want to forget to do my whole problem. So the domain are the values 1, 2, 3, and 4, and the range values are 10, 15, 20, and 25. Okay, I will try to upload this video. I'm having trouble printing here at school, but I will try to upload the video to the website. So if you choose, you can print it out and work on it if you, like I said, if you choose, if you'd like to.